Welcome to the Worked Out Solutions for the Limits quiz review. Let's take a look at number 1. We have a graphed function. Part A is asking us to take a look at the limit as x approaches -5 from the left. So here's where x is -5. Here is its function value here, but the limit as we approach -5 on the function is up here because as we're approaching -5 from the right, these are the values that we're at up here. And a limit is a y value, so the y value that we're approaching as we approach when x is -5 from the left is all the way up here at 7. So this one-sided limit is 7. As we approach when x is -5 from the right, we're also approaching the same value up here. We're also approaching y equals 7. So both of our one-sided limits in part A and B, our one-sided limits of -5 are both +7. And since both of our one-sided limits exist and are equal to the same number, that means the overall limit as we approach -5 is also 7. So in order for the overall limit to exist and equal a number, the left-sided limit and the right-sided limit have to both exist and equal the same number. Part D is asking us for f of -5. This is asking what is the exact y value when x is exactly -5. That is the coordinate point. So when x is -5, our exact y value is right here. It's at 3 because we have the coordinate point -5, 3. And then part E, it starts to ask us about 1. So we're asked what is the limit as x approaches 1 from the left. Here's where x is 1. As we're approaching it from the left, our function's down here. Our limit's a y value. We are approaching the y value of -3. Okay, let's take a look at these over here. So let's look at part F. That's asking us as we're approaching 1 from the right. So here's where x is 1. From the right, here's our function. As we approach x equals 1 from the right, our y values are approaching 4. So both of the one-sided limits at 1 exist and are equal to numbers, but they are not the same number. Therefore, the overall limit as we approach x equals 1, as x approaches 1 rather, does not exist, because the one-sided limits, although they exist, do not equal the same number. So we say that this here does not exist, DNE. And if you look, when x is 1, we can clearly see there's a break in the graph here. We're not approaching the same value as we approach 1 from the left and the right. All right, what is f of 1? What is the y value when x is 1? When x is 1, our y value is up here at 6, because we have the coordinate point 1, 6. And the last two are asking us about when x is approaching or equal to 4. In part I, as x approaches 4, what is the overall limit? Well, we have to make sure that the left and the right-sided limits they both exist and are the same number. So if we look at when x is 4, if we approach 4 from the left, we're approaching -2. That's our limit from the left. And as we approach x is 4 from the right, we're also approaching a y value of -2. So our left and right limits at 4 are both -2. Therefore, our overall limit down here is -2. And this is asking us for f of 4. When we plug in 4, what is our y value? There's none, right? If we plug in 4, there's an open circle here. This point is undefined. We do not have any y values when x is 4, so we'll write undefined. If you write does not exist there, that's also fine, but we normally use does not exist for limits and undefined for a function value that is not there. Okay, moving on to evaluating limits algebraically. The first thing that you want to do is use direct substitution. So the first thing I'm going to do is plug in 4 everywhere there's a z. When we plug in 4, we get an answer. So that is our limit, 12 over 25. For number 3, we also want to start with direct substitution, so we'll plug in -2. When we plug in -2 with direct substitution, we get indeterminate form, 0 over 0. So we have to use another algebraic method. In this case, we can see that the denominator can be factored. So what I'm going to do is we'll say this is the limit as x approaches -2. And then the numerator cannot be factored, but the denominator can be. Two numbers that multiply to negative 16 that add to negative 6 are negative 8 and positive 2. If you're unsure if you factored correctly, you can always multiply this out and see that you will get back to this original quadratic trinomial. All right, now the w's plus 2's can cancel. So we're left with the limit as x approaches negative 2 of 1 over w minus 8. When we use direct substitution here, we'll plug in negative 2 for w, and we'll get negative 2 minus 8, or negative 10. And we don't want to write the negative in the denominator, we'll just write it out front of our fraction. Okay, again, our first line of defense is direct substitution. So when we plug in 2 pi, we'll have 4 times the cosine of 2 pi. The cosine of 2 pi is 1. So this is 4 times 1, or 4. And that one wasn't too bad. Number 5, we're going to do a little multiplying out because the numerator is not in any type of standard form. So we didn't see any like this, but I thought I'd include it just for kicks and giggles here. Which you totally didn't have to do this first, you could just plug in first, but I just think this is easier. All right, so I did that first. If you plugged in 8 just to here, that's totally fine too, but I'm just going to plug in 8 to this. So when we plug in 8, all right, I plugged in 8, and we get 0 over 0, which again is indeterminate form. So we showed that we got 0 over 0. So what I'm going to do is take this and factor it. So we'll have the limit as t approaches 8, and then I can factor the numerator and the denominator. The numerator is a quadratic trinomial, so two numbers that multiply to negative 24 that add up to negative 5 are, let's see, negative 8 and 3. And then our denominator, there's a GCF of t, so I'll take the t out, and we're left with t minus 8. Okay, then the t minus 8 factors can cancel top to bottom, they're 1. So we're left with the limit as t approaches 8 of t plus 3 all over t. And when we plug in 8, using direct substitution, we'll have 11 over 8. All right, we'll first plug in 3 to use direct substitution first. And we got 0 over 0. I'm sure you can sense a pattern here. If something looks factorable, then I want you to factor it. So we do have to establish that we got indeterminate form, and then we can factor. So the numerator is a difference of squares. Perfect square minus another perfect square. So this will factor into x plus 3 and x minus 3. The denominator is, once again, it's our third one, our quadratic trinomial when a is 1 here. It's just x squared, right? There's no number out in front of here, just a 1. So two numbers that multiply to 3 that add to negative 4 are negative 1 and negative 3. And then we can see that the x minus 3's will cancel. They're 1 when they're divided by each other, so they cancel to just a 1. So we're left with the limit as, I don't know why I wrote a t there. Whoops. I did not mean to write a t. It's an x. All right, the limit as x goes to 3 of x plus 3 over x minus 1. And then we can use direct substitution, so we'll plug the 3 in here, so we'll get 6, and then down here we'll get a 2. And that comes out to 3. Okay, once again, we'll start with direct substitution, and I messed this one up. I realize I have an a there, so that will be fixed by the time that this gets sent to you guys. So I need to put an x there. All right, so here we go. So I'm going to plug in -1. So this is 2 times -1 in the numerator and -1 plus 1 in the denominator. And it looks like we'll have -2 over 0, which is undefined, right? So undefined is a non-zero value over 0. Indeterminate form is 0 over 0. And 0 over a non-zero is just a regular 0. But we cannot divide by just a 0 when there's a non-zero up here with limits. So this is undefined. And that means that this limit does not exist. And lastly, I sort of just talked about this, but what is indeterminate form? Indeterminate form is a lot of different things. Namely, it's 0 over 0 with limits. That's the one we've talked about, but indeterminate form is also infinity over infinity, or positive or negative infinity. So I'm just going to put plus or minus here. But this is really the one that we care about right now because we haven't dealt with infinities yet. So when we have 0 over 0 or an infinity over an infinity, either positive or negative, that's called indeterminate form. Again, don't worry too much about this one yet. This is the one we're concerned about. What does it mean in terms of limits? It means that the limit could still exist. So when you get indeterminate form, the limit can still exist. We saw that in a lot of examples when we got 0 over 0, and we still factored and then used direct substitution in order to find the limit. So indeterminate form means that there's still potentially a limit, and we can still find it using other algebraic methods. All right, I hope I didn't talk too fast and you got a decent review, and best of luck on your quiz. Bye-bye.